Hello, Tibor. Welcome. Thank you so much for making the time to meet me here today.
Thanks for inviting me.
So, Tibor, I hear that you're a very keen sailor. Did I hear this right?
I am, yes, indeed. Sailing has been my passion since I'm 4 years old.
Wow.
And sailing has a lot to do with digitalization as well. I've been following the America's Cup, for example, closely over the last years. If you look at 2003, where the Swiss boat Alinghi sailed, one monohull with 17 sailors and just speeding around 10 to 13 knots, the digitalization at that time was limited, right? So all the decision on navigation and trim were mostly based on the team's experience. So in 2024, the situation was completely different. Here, Alinghi partnered with Red Bull Sailing and came out with boats with foils, which allowed the boat to get out of the water and sail much faster, literally 40 to 50 knots. This was thanks to a lot of data and telemetry that got captured from the sails. So they could see the sail shape, the loads on the boat, and also the foil angles. And they could make use of the hydraulic power that was also used with joysticks and push buttons to really have this on millimeter as they needed it to be, right? This was a revolution basically in sailing, using much more data and be much more precise, more efficient in the way all this boat could run. And in the grid, we have, of course, similar developments also where we digitalize the grid, right? So old manual electromechanical relays got replaced by intelligent electronic devices, so-called IDs, which also got connected with digital 61850 communication bus. And also in the grid, we capture more and more data with sensors everywhere, which help operators to better understand in real time what is happening and take better decisions. So with that, we make the grid more efficient, more sustainable, and more safe.
Thank you. Very interesting parallel. I wanted to ask you if you could tell our listeners what your job really is in very simple terms. What do you do?
Well, what I usually say is that we ensure that power gets from where it's produced to where it's needed. In simple words, imagine an offshore wind farm that produces green energy, or a very large data center that consumes a lot of power. These need to be connected to the grid, and typically this is done with substations. And for these substations, we provide automation, protection, and communication. The automation ensures that everything runs smoothly without constant manual intervention. The protection ensures that there is no fault harming the equipment. And the communication ensures that all the parts of the grids are talking to each other.
So in this period of the energy transition, how do automation and communication solutions help the grid?
Yeah, so traditional grids were designed for one-way power flow, right? From large fossil fuel plants or nuclear power plants to consumers. Now, with the introduction of renewables, wind, solar, and distributed energy resources like rooftop solar, or battery energy storage, we are having bidirectional power flows. These power flows are difficult to predict and very dynamic. So our solutions are supporting customers to better understand these dynamics and manage them properly. Being able to manage those, see them, allows them to, with confidence, to deal with the energy transition and also include the additional resources going forward.
And do you have much experience in this area, as in you, Hitachi Energy?
Hitachi has been a pioneer in grid automation and has over 110 years of experience. We have a lot of domain expertise, and we have also supported heavily the development of the 61850 digital communication standard. We've been the first one globally to deliver a multi-vendor 61850 solutions in 2004. Since then, we've delivered thousands of systems and products. We also recognized as the number one supplier for grid automation. And this was also recently confirmed by a market study of the ARC group.
Right. Quite often, and especially more recently, digital substations are becoming more mainstream. Is there an advantage to a substation being more digital? And are your customers requesting this more and more, do you find?
Yes, so maybe a first clarification, digital substations. So modern substations today are already digitalized a lot, right? I talked about the IEDs and the process bus, which is digitalizing a big piece of the substations already. When we talk about full digital substation, we speak about digitalizing the remaining piece from the IEDs to the field, the primary equipment. So here we're replacing the single copper wires that connects these equipment one by one to the IEDs with a process bus, and are deploying sensors in the field or so-called merging units. This allows us to capture a lot of more data, and there's a lot of advantages going digital. First of all, there is a safety aspect. Means that there is no risk of electrical shocks by touching these old copper wires. We save a lot of space, so control rooms are much smaller, up to 60% than what they were before. We save a lot of wires, so instead of these one-to-one connection, we have one bus, up to 80% less of wires. We gather a lot of more data of what is happening in the field, right? So this allows us to better manage and use this data also with artificial intelligence for predictive analytics and maintenance, for example.
So can you tell us why distribution automation is becoming a growth area alongside transmission?
Well, distribution networks are growing even faster than transmission. That's where also consumers or customers feel the energy transition most. We have a lot of new loads like electrical vehicles charging, data centers, or heat pumps. These can bring hikes of consumptions which are difficult to predict. We have the distributed energy resources like the rooftop solar and the related batteries, which are introducing bidirectional power flows. So sometimes they consume energy, but sometimes they also inject back energy. And we have a grid that was not really designed for it, is partially very old. So there's a lot that needs to be done in the distribution automation network to be able to handle those new dynamics. And we want to be part of this journey and bring in all our expertise from the transmission also into distribution. We are expanding our solutions and our portfolio to support customers to manage this transition well.
Would you be able to share a customer success story with us?
Yes, sure. We have a nice success story with Ørsted, where we have partnered together to overcome a challenge of protecting the long and powerful cables that are connecting the wind farm with the grid. These cables have special characteristics and behave a bit special and are difficult to protect with the conventional protection we have.
Is it a challenging project because of the length of these cables? Is that what makes it tricky?
Yeah, well, indeed. So these cables are very powerful. So they behave like giant batteries.
Right.
And when current is flowing, this creates a big charging current. The protection is not fully clear on whether it is a fault or not a fault, right? That is one aspect. Then there are other aspects like when breakers are opening and closing. This creates a kind of echo also on the line. And the protection is also not sure whether this is a fault or not.
Right.
There's also another effect, like having different cables, also different cable sections, which are not exactly all the same. And all that can confuse the current protection systems that we have. So that's why we have developed a new adaptive model-based differential protection, which can much better analyze and detect those faults. Therefore, we have less outages and can run these wind farms much more efficiently. Because the other solution would have been to reduce the sensitivity of the protection. And with that, of course, we risk that we cut the power more often than we need, or have it less sensitive and then risk to harm the equipment by having a fault.
But these faults don't happen very often. So I know breakers don't go into action very often at all, for example. So that echo wouldn't happen.
They don't know typically. Yeah. So what has happened so far is that indeed, I mean, the sensitivity was rather brought down to make sure you capture the fault. But that meant that you have more often outages, which is something, of course, you don't want unnecessary outages.
Okay. So as a last question to you, what would you want your listeners to have as the main takeaway from this episode?
Yeah, I mean, one takeaway would be to say it's not only about making the grid bigger, it's a lot about making the grid smarter, right? Just like the sailing boats I mentioned at the beginning, they need a lot of data to be out of the water and sail fast. And the grid also needs a lot of automation and communication to be able to deal with the renewables and, as we also said, the new energy consumption like EV charging that we have. So we from Hitachi Energy do deliver the digital infrastructure and solutions that help customers to move more from a more reactive state to a predictive state, and therefore navigate with confidence through the energy transition. So with Hitachi Energy, you're not just making up with the energy transition, you're leading it.
Great. Thank you so much for coming in today. It's been wonderful chatting with you.
Thanks a lot, Barbara.